All right, let's talk about something pretty much every Java developer thinks they know how to do: reading a file. It seems so basic, right? But what if I told you the most common way to do it can actually be a huge performance killer? We're going to dig into how Java really handles files and, more importantly, how to do it the right way.
So let's get right to it. How does your Java program actually get the data out of a file? You probably imagined it just cracking the file open and grabbing everything inside. But well, what's really happening under the hood is a little different, and understanding this one thing is the key to everything.
Okay, here's the twist. Java doesn't read the file at all. That's the first big idea you've got to flip in your head. Instead of dealing with the whole file at once, your program interacts with something else entirely.
It reads a stream. Think of it like a river of data. Your program doesn't just swallow the entire river in one gulp, right? No, it sits on the bank and takes in the water as it flows past. That flow of data from a source like a file into your program, that's a stream.
And this right here? This is the mental model you need. The file is the source of the river, and Java opens up this data stream that your program can sip from one piece at a time. So with that in mind, let's see how developers usually try to do this for the first time.
So, how do we actually tap into this stream? Let's walk through the most basic approach, which is reading a file just one single character at a time. First off, let's clear up something that trips up a lot of developers. There's a class called file, which seems like the obvious place to start, but if you look at its methods, you'll see there's no .reading. That's because its job isn't to read the data. Its job is just to represent the file's path. It tells you where the file is, not what's inside it.
To actually read the characters, we need a different tool from our toolbox, and that tool is the FileReader. It's built specifically to connect to a file and give us that character stream we were just talking about. Let's see what it looks like in code. Here we go, a complete bare-bones program. See how we create a file reader pointing to our test.txt file? Then we just call the .read method over and over again inside a while loop, printing each character until .read tells us we've hit the end of the line.
So let's just quickly break down what's happening. We create the file reader. Then the magic is in the .read method. It grabs a single character and gives us its integer value. We keep looping and calling .read to get the next character and the next and the next. Once there's nothing left, .read returns -1. That's our cue to stop. Simple as that.
This is the perfect spot to just hit pause and try this yourself. Seriously, make a little text file, whip up this code, and watch it work. There's no better way to really get a feel for how this stream works. Okay, so it works, it's straightforward, easy to understand, but it's hiding a major problem. We've just walked right into what I call the efficiency trap.
Let me just ask you, if your file wasn't a few words but was, say, a gigabyte, do you think this one character at a time approach is going to be fast?
Yeah, the answer is a hard no. For any file that's not tiny, this method is painfully slow and inefficient. But the really interesting question is, why? What's actually going on that makes it so slow? The answer is buried deep in how your program talks to the computer's hardware. See, every single call to .read isn't just a simple little operation. It's often what's called a system call, a formal request to the operating system to go and physically fetch a piece of data from the hard disk. And, as you can see from this data, system calls are expensive. They eat up a ton of CPU time. So if you read 1 million characters one by one, you could be making 1 million of these costly trips. That's our bottleneck. Now, before we fix that performance problem, we've got to cover a non-negotiable rule for working with streams. This is something you have to do every single time. A stream is what we call a system resource. It's holding on to things like file handles and memory in the operating system. And the golden rule is this: any resource you open, you absolutely must close.
If you forget to call .close, your program causes what's known as a resource leak. The operating system thinks your program is still using that file, even though you're done with it. It's like leaving the tap running. Do that enough, and you can slow down or even crash the whole system. So the main point here is always close your streams. Now, back in the day, we had to use these clumsy finally blocks to make sure close was always called. It worked, but it was ugly. Thankfully, modern Java gave us this beautiful, clean solution, the try with resources statement. You just declare the stream right there in the parentheses after try, and Java itself guarantees it gets closed automatically. It's safer, cleaner, and way easier to read. Okay, with our safety rule firmly in place, let's get back to what we were talking about.
how do we escape the efficiency trap and make our file reading actually fast?
We know the problem, right? Too many of those super expensive system calls. So, logically, the solution is to make fewer of them. But how can we do that if we still need to read every single character in the file?
The answer, my friends, is buffering. Instead of making one single system call for every single character, we make one single system call to read a big chunk of the file, like say 8,000 characters, into a temporary spot in memory called a buffer. Then, when our program asks for a character, it gets it from that super fast buffer, not the slow hard disk.
And in Java, the go-to tool for this is the buffered reader. You just wrap your file reader inside of it. The buffered reader handles all the heavy lifting of reading in big chunks behind the scenes. So now, instead of 1,000,000 system calls for 1,000,000 characters, you might only make a few hundred. For large files, the performance difference is just night and day.
So let's boil this all down. What are the key things to remember? 1. Stop thinking files, start thinking streams. 2. Reading character by character is a performance trap because of all those costly system calls. 3. You always have to close your streams, and you should just use try with resources to let Java handle it. And finally, number 4. For real-world performance, wrap your readers in a buffered reader and let buffering do the work for you.
You've now got a solid model for how Java reads data from a file efficiently and, just as importantly, safely. But that's only half the story, isn't it? What about going in the other direction? How does Java handle writing data to a file? Well, that sounds like a perfect topic for our next explainer.